Hello everyone. This is asynchronous lecture recording, and we were continuing our topic, that is file organization and indexing. So far in the previous lecture, we have seen about a few terms, that is a fixed length record, variable length record. We have seen the span organization, unspan organization, block factor, and multi-level indexing, all those. Right. So now let's continue further and we'll start the topic, that is your category of index. So how we categorize the indexing part. Okay. First is called your dense index. What is dense index? Remember, for each record of database file, there must be an index entry in the index file, right? So that is what the number of index entries will be equal to what? The number of records that we have of your database file, right? So let's understand with the help of an example. Means let's say this is your database file and we have the blocks this way: B1, B2, B3, B4, and so on. Some attribute A is there and we have the value, let's say 2, 4, 6, 8, 10, 12, block factor 2, 14, 16, and so on, right? So our block factor is 2 over here, right? Now what we will do is, let's say understand first, when we have see in dense index, in the dense index, again we have two situation. The one is if our field, that is this one, is ordered field or unordered field, right? Now for this part, in this one, since we can see that the field is ordered here, right? Now let's say the block factor for index file is your 4, means what? It can record 4, it can have 4 records over here, that is our pointer and your A attribute value, right? So that is what we have: 2, 4, 6, and 8. This is what your one block, B1, right? Then 10, 12, 14, 16, that is B2 block, in this way, right? Then you can have the rest of this. So now in this one, see, these are the pointer, that is the addresses, and we point to every blocks elements over here. This is what your dense index, right? Means for every record we have the pointer, or say the value, in the index file, that is your dense index, right? So this is what in the shorted, see, this was ordered field. Now let's say if the field is not ordered, that is unordered field, then what will be the index file looks like? Let's take B1 block, B2 block, B3, B4, and so on, let's say, right? Now take the values, let's say 6, 10, 4, 12, 2, 16, 8, 14, and so on, let's say, all this. This is your DB file with block factor equals to 2, right? Now this will be what? Our index file, right? This is your index file. Our block factor is 4 over here, let's say. See, there is a concept, you can see the block factor in this disk file is of size 2, while the block factor is of size 4 over here. There is a reason. In the upcoming sessions, we will see why the reason is this, that the size of the block, that is a block factor size, is more in index file. Why the reason behind, we'll see that, right? So now let's say, even with the help of numerical, we'll understand that. So this one for index file, right? So what will be, what we can have 4 records over here, right? In this way. But as I told you, when we understood, the entry in this one will be what? Ordered only. We cannot have unordered field values in the index file Here we have unordered values, right? So that's why when we perform the indexing, always remember we take the values and sort them in the order, right? So what we'll have 2, 4, 6, and 8, and these are the pointers. So this 2 will be here, 4 will be here, 6 will be somewhere here, and 8 will be here in this way. Then we have what, 10, then it comes 12, 14, and 16. Again the pointer, and will point the values, right? So again index, the dense index is there for every record. We have the pointer, right? And the value, that is what we'll get. This is your anchor attribute, right? The values will be always in the sorted order, right? So an unordered field, it becomes or say must we use dense indexing. Remember, when we have unordered field like this one, there is no alternate we are left with. We always use the dense indexing, right? We will see when we see the sparse indexing why we use this one. An entry in the index will be ordered only for this one, right? So this is your dense index order, right? So now the second, that is called your sparse index. So what actually the sparse index is? See, for the set of database record, there exists one index entry in the index, right? So means the number of index entries. See, index entries here is same as number of record in this one, because we have index entry for every record in this dense table index, right? In sparse index, the number of index entries over search key, we have seen search key. If search key is your candidate key, we'll talk about candidate key only. This value will be equal to what? Number of blocks of your database file. Yes or no? Right? So how? See, for example, taking this one, A will take this same database file record, that is 24 for block B1. We have block B2, B3, and let's say B4. These values are in sorted order. Yes or no? Okay. These values are in what? Or these ordered field values in this one. Okay. So block factor 2. Now when we create the index table for this one, we have the pointer and a attribute value, right? Block factor, let's say its size is 4 again. So but we have 2. So we'll keep the record for this one in the index file. This record will be only the one entry of this block, right? So again we have 6 after this one, that is for this one. See, remember one thing. I mean, why, if you can have a question in mind, why we are taking 2? We can take 4 also. Yeah, definitely. We can take any record. We are not restricted to over here, right? So remember this thing. You can take any record, because ultimately we understood in the previous class. Ultimately, our goal is to access the block. When we access the block, we can access the record inside the block in no time, right? So the important is we need to reach to the correct block first over here, right? So that element can be any of this block, right? So after 6 we have 10 for this and 14 for this one, that is for block 1. Same we have block 2 and so on, right? So this is what your sparse index. So you have understood one point, you have understood clearly. You can apply sparse index only when you have ordered field. That means the search key is the order, that is a sorted order, right? So the search key is basically the candidate key. There is no problem. This is candidate key, but it should be sorted also. only then you can apply sparse index, right? Value should be shorted. Okay, why we have taken the candidate key? Why it cannot be any other key over here? That is, let's say, key other than candidate and alternate key, right? So if what the problem is in that case, if we are having the candidate key, we know that every value will be unique, right? That is unique and not null, we have seen. But if we don't take the candidate key, we can have the repeating values, right? And that is what it all about, your cluster index. So when we have the repeating values, again we can have two scenarios. The particular field can be ordered or it can be unordered with repeating values. So that we, in that case, we use cluster index, right? So we'll see all those things, right? So category of your indexing, we have seen we have two index. We have dense index and we have the sparse index, right? So just a quick revision for the previous session. We will solve an example over here. We understood about the file indexing, right? And we understood the structure. We understood, consider an example over here, right? And we get to know what is the block factor, how we find out, right? And we then understood the input output cost for your ordered field, that is in shorted, and unordered field, that is not shorted values in this one. We understood, remember this, we understood for shorted field we want to get the value, the time IO cost or say time complexity is log of n base 2, right? The flow value. And for ordered field we have n blocks, then as many number of blocks that we have, this n is also number of blocks, right? And okay, then we saw the fixed length record, right? And variable length record, and the span organization and unspanned organization. So these all we have seen in the previous class. Now let's solve a question. I told you the very important part is you will get the numerical from this one, right? So I have already written a numerical over here. So we'll try to solve this. Okay. Okay, so the question is, this is very important. You will get the similar type of numericals in the exam. So, and easy also. The thing is, you need to understand the length of the question might be, large lengthwise, right? So don't just try to afraid on all those. It will be easy. Understand one by one. Let's say a file consists of 1 lakh records, right? So with record size of 100 bytes and block size of 1024 byte, that is 1 kilobyte. See, the search key size is 12 byte and pointer size is 6 byte. So we have seen, right? So the scenarios that is given to us is something like this. In the disk file, that is the database, how many 1 lakh records that we have? This one. These are the records in your disk database file, right? Now we create the index over here. This will be our index file. So in between, in this one, we can use either sparse index or we can use dense index, yes or no. And we find out how many records we can have over here, right? Okay. So now let's see what informations are given. We have the record size, that is record size is of 100 byte, and block size is your 1024 byte, right? Search key size is there, so that is a 12 byte, and pointer size p and k values are given. Okay, we'll see that later on. Okay, let me write over here. Key size, that is k equals to 12 and pointer size p equal to 6. We'll put in the formula, right? So now first try to find out the block factor of your index. Okay, before that you can find out the block factor of the disk, right? So the block factor, see, we haven't read the questions right now. But let's see what information we can retrieve from the given values. The block factor of your database is what? The formula B minus H by R, this one, right? So B is your block file, R is your record size. So block size. So block size we have 1024. See, H is not given. So whenever it's not given, we use the value 0, right? So that is what 1024 minus 0 by 100 and the flow value. That is what 1024 minus 0 by 100. That is, it will be around 10 because we have to take the flow value. See, this is the lower bound. Remember why the lower bound as see, because the thing is we use unspanned organization. Right, so that's why we understood in the previous class also. We use the lower bound and the values out to be 10 block, right? Okay. So this is the block factor, that is in the single block we are using 10 records. But how many blocks are there? So that is number of blocks of your database. That is what, how many total records? Basic mathematics, 1 lakh divided by how many records are there in one block. That is right now we have calculated 10, and we take um, upper bound value, that is this one seal value, and we'll get this one. Okay, so 10,000 is your block. So basically we have 10,000 blocks in the database, right? Because the thing is, actually remember why we have taken this. In the block, let's say we have organized the record in the block, and in the last we got a block, or say we left with one record. So definitely for that one record we are going to create a block, and we have to use that also, and that will be used as a complete block, right? So that's why. So we have find out for the disk, that is block factor and the number of blocks. Now check for the index. Now the block factor of index, right? So now index, as I told you, it can be sparse or the dense. Now let's check for the dense one. What should be the block factor if we use the dense indexing between this? So for that, what we have, again same formula, this one B minus H by R, right? So what will be that? 1024 we know, minus 0 by what is the R now? See, we use this one index. For index, the information is given. In index, we know we have a pointer and we have a search key, right? That is k value. So its value given. The pointer is of 6 byte and key is of 12 byte. So the denominator value will be k plus p. This R is, it's not actually, it is k plus p over here. Right, so that's for 12 plus 6, 18. So it's 18 byte. So this one. So the value will be, it's again flow, and it will be around 56. Right. So this is what we have, the block factor of index. Fine. Now if we use the dense indexing, but if we use the block factor of index in case of sparse, right? So in this case, in the case of sparse index, the block factor, okay, will be what? Again, how many, see how many blocks are there in this one? Number of blocks. For this one, sparse index, remember, how many blocks will be there? That is equal to number of blocks in the disk, right? And we have calculated this one, that is this one, 10,000. So 10,000 divided by how many record will be there in the single block, right? So that is what, 56. Right now we have calculated using the dense. Why? Remember, see, whenever we create this the block inside the index, that is one block, How many we can have? We have calculated, like if we create the indexing for each record in this one, we can have at most of 56 record, right? So if the 56 record are there and we have these many blocks, that is 10,000, right? Then how many, what should be the block factor then in that case, right? So its value should be, I guess, around 179. These are 179 blocks, right? So in this case, remember, for now, okay, so this is basically, we don't say this one. This is basically the number of sparse index block, right? That is your 179 blocks are there. In the same way, we can calculate the number of dense index block. So what will be the number of record? That is 1 lakh. Uh, okay, right? And divided by your total block factor of index, that is in dense, that is 56 again, and we get the value. It's around 1786 block. See, with the sparse index, we have 179 blocks, but with dense index, we have 1786 blocks over here. This is the difference. When we create the indexing, if we have the dense indexing, the blocks created are 1786. But in case of sparse index, we have only 179 blocks over here. Okay, let's see the question. What's asking? Input output cost without index. Okay, so what is the input output cost without index if search key is ordered? So we know if the search key is ordered, the formula is what? Log n. N is basically the number of blocks over here, right? So that should be log of n, that is base 2, the seal value. This n, number of blocks, when we have the ordered search key, right? What is that? 10,000. This one, number of blocks, right? So the value for this one is around, let's say, 14 block. It will be some 14 block. Remember, remember one thing. We add the one value, so that is 13 plus 1, right? So 13 plus 1 is your total cost. Why we add 1, we have seen. If we got the pointer value, again one additional cost will be there to search that pointer value in the disk, right? Okay, if the search key is unordered, we know it's an order of n, right? So that is n equals to 10,000 blocks, right? We need to search every block over here. Okay, if a dense index is used, the number of blocks in the first level index, right? So we need to find out the number of blocks. That is what this one, indexing is used, the number of blocks is 1786, right? So it's 1786 blocks are there, right? Input output cost for this one, we have the dense indexing, right? So for first level, right? So it will be, the formula remains the same, the value will change, log of n base 2, and that is this plus 1, right? So we, in this one it's already done, 14, 13 plus 1. So n value for dense index, the one, what's the n value we have calculated, that is 1786, right? So log of n 1786 is around 11. So 11 point something, so 11 plus 1, that is 12 block, right? Now, if sparse index is used, number of blocks in the first level indexing, that is this one. How many? 179 blocks only. So this is 179 blocks. And the cost for this one, again, same formula, only n value will change. That is log of n base 2 seal value, and n is what? 179 plus 1 is there, right? So it's around 8 point something. So that is 8 and plus 1, that is 9 block. So you can see the input output cost is, it means we need to, if we use the dense index, we need to put at least the 12 blocks to search the value. But in sparse index, the blocks is reduced to 9. And this is what the benefit if you use the indexing and sparse index rather than dense index, right? So in this way, we can solve the numericals with indexing and with dense and sparse indexing, right? Okay, so now let's continue further. Now let's see what are the different types of index. Okay, so let's make a tree diagram and understand. Index. We categorize first them based on search key, right? Search key. If the search key is your ordered field, that is what? The sorted elements, right? And if the search key is your unordered field, right? Okay, the search key basically used for indexing, right? So we already know. Now, if the search key is ordered field and your search key is either primary key or alternate key, we have seen, right? If primary key or alternate key are there, remember, if the search key is this, then we always use primary indexing. Primary index we will use, right? So now, other scenario for this is search key is non-key. Non-key means the key other than primary and alternate, right? So we use, in that case, we use clustering index. We use clustering index, right? Now come to this side. Same scenarios here. If our search key is primary key or alternate key, right? Then we use secondary index over key. Secondary index over key. But if our search key is non-key, we again use secondary index, right? Remember, we say secondary index over non-key, right? So anyhow, we have three different type of indexing. One is your primary index, other is your second cluster index, and then you have secondary index, right? We will see all these three one by one and what's the basic difference between them, right? Okay, so let's first start with primary index, right? Primary index. We define what is the search key. The search key is your ordered field and your what key part, that is primary key or alternate key, right? Okay, understand with the help of example again, although we have seen this example so many times. Let's say eid is the key, right? We have the value 2 4, block factor is your 2, means you can have two records and these in a single block, and these are all what sorted, means in the order, that is say the ordered field, right? In this way, some values and so on, we can have as many records over here, right? So our first level index, as we have seen right before, this is your first level index, right? So since field is ordered, right? So remember, we are talking about primary indexing now, right? So since the field is ordered, we have seen, and we are working on the key part. So what we will do is, in this pointer and this eid as the anchor attribute, anchor field, we have the value, one value for each block. Yes or no? Let's say the block factor for this is 4. It means for record can be kept in the single block over here. The second 6 for this one, then we have 10 for this, and then 14 for this one. That is one block, right? Then we have 18 and so on for other, let's say it's 18 over here and so on. We can continue. So this is what primary index, right? Even you can do further second level indexing over here, right? It will contain 2 and then it will contain 18 in this way and so on till we have one block. That is for multi-level indexing, right? So, and this is what ordered field, important one. This is important. This is ordered field. Then we have the sparse index in between your disk, database file you say, or the indexing. This is for your index. That is called a primary index in this case. Remember, IO cost to access the record using primary index with multi-level indexing is k plus 1 record. For example, this is your kth level index, primary index, right? So the IO cost will be k plus 1. Till k, you will search the value and then you get the pointer value, you will see the disk file, right? Some important points are there you need to remember about primary indexing. That is what the primary index can be even dense or it can be sparse, right? We have categorized the indexing, right? So we can have dense also and we can have sparse. In this case, what we have the sparse, but remember, whenever we use the primary index over the key, we use the sparse primary index. That is your sparse indexing is used over here. That is your preferred, right? For any database relation, at most one index, that is one primary index is possible. This is important. You need to remember in any database, you can have exactly one primary index. You can say at most one, right? So why? The reason is we are building the primary indexing on what primary key, let's say, right? Or you can have alternate key as well, right? So when we have building the primary key, we know that in the database relation we have only one primary key. We cannot have more than one. So that's why indexing is also, when you're building index file on that primary key, we can have only one primary index, right? So such keys must be ordered field, that we know, right? So this is what your primary indexing is, right? Okay. Now see, let's see the second, that is clustering index. And remember, when this the value ordered field values are not in sorted order, we cannot use primary indexing, right? Okay. So now let's see the cluster index. What is the search key over here? That is again ordered field, right? But it's non-key. Means element will be sorted, that's fine, but it's a non-key. Non-key means we can have a repetition of values. For example, let's see, this is what your database, this we have block b1 with value, let's say 2 and 2. For block b2 we have 2 3. Now let's say 3 and 3 is there block for block b3. Again we can have 4 values of 3 repeating b4. We can have b5 with 4 and 5 in this way, and this continues. Block factor is 2. This is your disk, and this is what your, let's say, department number, for example, because, and we have employee name, because one employee it means a department can have many employees in that way, right? So we have other values also, let's say a and b in the department, we have a b c 3 employees in that, right? So cluster index, it comes when again this field, see this field is your ordered, means we have the value in the sorted order, but these are non-key, means non repeating values are there, it's not the key part, right? So ordered key plus non-key, we use cluster index. So how we use the cluster index, see how it is made. as we know, when we make the cluster index, any index file we will make, right, the element will always be in the sorted order, right? So let's have two over here, right? So this is what pointer, and this is your anchor attribute department number. This two will point over here. But see, the thing is, this two is present, okay, here, that's fine, but this two is present in this block also. So there is a requirement of some additional information. And what is that? Remember, in cluster index, for every block, we store a pointer that points to the next block, right? So every point, there will be a pointer. We have seen this one. So every block will have the pointer to the next block in this way. So, and see, and this is the reason, then we, when we find the value 2, we will see in the next block also if it is available or not, right? So there is an effect on what we have seen in the previous class. There is an effect on your access time, because anyhow we need to check the second block as well, right? But there is a not so effect because we are having the pointer to that block directly. Okay, in this way we have 3. So 3 is stored over here, and then what we have 4 and 5 in this way. So 4 here, even in the same block, 5 over here. Let's say block factor is 4 for index. This type of index is called your clustering index. Means when the field is ordered but it's a non-key, we use the cluster index, right? So number of index here, it will be equals to number of cluster, right? And now after this one, if you have created this one, now you can create another if you want. There you have two values over here. Let's say in this one it can be 6, right, pointing to this one, and then you can have 6 value in this way and this way. The next level, that is second level indexing, you can do in that way, right? So one block is there in the last. So basically the idea is, in this cluster index, when we have the known key but ordered field, we have to use cluster index. There are a few points to remember. Remember, cluster index mostly behave like a sparse index. It mostly behaves like a sparse index, but can also behave like a dense index if each cluster is with one record. Yes or no? Right? Because see, for any database relation, remember, at most one cluster index is possible, right? And for any database relation, either primary index or cluster index, but not both, right? So remember this thing, right? Okay. So there is a point, that another point that we need to take care of when we are building multi-level, indexing over here. The input output cost to access the cluster of the record, that is the cluster index with multi-level indexing, is what? That input output cost, right? So that will be actually, that is input output cost of clustering index, equals to k. K means the how many levels in multi-level indexing, MLI, right? Equals to k, the level of indexing, plus one or more block of database. Let me write one or more block of database until next cluster. Remember, next cluster first block access to the main memory, or say the disk, this one, right? So if you are not understood, let me just take an example. If I'm saying that cluster size, see how the numerical will come in this one. If I say the cluster size numerical will be given as a 16 records, right? And the block size is your 32 record, right? It is saying that if k equals to 4, means 4 level indexing, with that is multi-level indexing with cluster index at first level, then what is the worst case? Because see, This is what the cluster size, right? In this one, first we have the cluster index. After this, as many level you will make, you can use the sparse index, because you have got the sorted, right? And after this one, any level you can create is the sparse index. So we say it mostly behave like a sparse index. The reason behind it is not a dense index means we have understood the definition of dense index. Dense index says that for every record you must have the index, or say the pointer in your index file, that is set by your dense index. But sparse index doesn't say the same. And the reason is it's not dense index. Why? Because for this two, we have the record, but we haven't used this two multiple time in this one. So that is why it is not dense index. So we say it mostly behave like a sparse index, as I told you, right? But it can behave like a dense index also if cluster is with one record, right? So that is actually not the scenario over here. Now it is saying that the cluster size is 16 record, it's not one record. So definitely we can use your what, the sparse index, right? But question is saying that if k equals to 4, that's the multi-level indexing with clustering index as the first level, right? Then what is the worst case input output cost, right? So what is the worst case input output cost? So we know k equals to 4. This is what the formula, plus one or more block of the database. So that is what you need to find, block size by your cluster size. Means after this one, means at the sixth level, or say the six blocks are required in this case. That is what 4 plus what 32 by 16. That is what 16 to that is 6, right? So six blocks, that is the input output cost you need to retrieve from the index file to get the value record, right? So this is what the numerical generally used to come, right? Okay, so you can just let me know if you have any doubt in this one. The third one is your secondary index, right? So secondary indexing. Again, we define what is the search key, that is unordered now, unordered field with key or non-key, right? So secondary index, remember, is an alternative index to access data record using index. So remember, before we apply the secondary index, actually what's the use of the, and why use the secondary index? We can use the secondary index before we have already either primary index or cluster index. We already have existing this cluster or primary in our database. Now it's an alternate. For example, the reason is, for example, let's understand with the real life scenario. Let's say this is your database, right? You have for student, let's say student roll number, you have ordered field 2 3 4 5 6 7 8 in this way. These are the blocks that you have created, right? These are the block. Now you have set in the record that you want to see. We use the indexing. Why we set the index based on the one attribute? Why? The reason is we generally use to work on the particular field. For example, we are very frequent to access the record of the student using their roll numbers. So that's why we have set this as a key and we designed our index file. But now let's say this is not the every time possibilities. For example, you have the marks of the student, right? Now you want to access the record using these marks only for the student. Means now this frequent search key is your marks rather than your roll number. But you have designed primary index, right? So that is on your key part, that is roll number. So that's why for that the particular primary key will already existing in the database, that is on your roll number, right? Now on the top of that we will create a secondary index file also, and that will be on the marks now. right? So that's why and see, we know that it can be in unordered field, means marks can be obviously in unordered, right? But this can be a possibility, the marks are all unique for every student, or it may not be unique, right? So that is key or non-key, the marks can be key or non-key, right? So one or more, remember one more thing, one or more secondary index are allowed in the database, right? So for example, this is the record, you have attribute x and y. If this x is your ordered field, then this indexing will be your primary, or say the key is primary key or alternate key, or say primary indexing or cluster index. Let's say, let's write key index only, ci cluster index and primary index pi. But if this y is your what, unordered, this will be what, this will be your what, secondary index, si. Yes or no, right? Okay. Now first let's see about the secondary index over key. That is secondary index over key. Okay. So let me take an example, and let's say this is our database. Um, Again, ordered field, unordered field is there. So let's say some pp number attribute is there for employee. We have values 4, 8 in block 1 to 10. It should be unsorted, unordered. 6, 14, let's say 18, 12, 24, 22, 16, 20. Let's say these values, 6 blocks are there. Again, we can see block factor is equals to 2. You have the disk file over here. You can have other attribute as well, right? So our secondary index will be, right? Okay. So see, in the secondary index, let's say our block factor is 4. So we can have 4 values. Since the values are unordered, you can see. So we have seen when our key values are unordered, we use dense index, right? And remember, in the dense index, our values will be, that is key values pp number, our value will be sorted. So we find the value in the sorted, that is, let's say we have 2, then we have 4, 6 and 8. Yes or no? So 2 is present here, 4 is present here, 6 is present here, and 8 is present again here, in this way. Then we have 10, 12, 14, 16, and so on, 18, 20, 22, then we can 24 in this way, right? So block factor is 4 over here. So this indexing, you can say 10 is present here, 12 is here, 14 is here, and 16 somewhere around here. So this is what your secondary index over key, that is actually dense, right? So after this one, you can use sparse index, right? And you can store the value 2, 10, 18 in this way, and for this each and every block. This can be your sparse index now, because we know index, whatever index value we have here, these are all sorted, and you can create a sparse index. So secondary index over key is always dense index. Remember this key line, right? So IO cost again to access the record using secondary index over key with multi-level indexing will be again k plus 1. So you can have other second level, till then you can have k level, right? K level. So IO cost will be k plus 1 blocks, right? So easy one, not difficult, right? So we take the values, sorted, pass, have the pointer to every record. This way, the secondary index over keys, you're dense again. Okay, what will be the secondary index over non-key? Okay, so what will be that? So let's understand. um, Disk file, let's say some department number again. This time we have 341 block, 25, 23, 26, 33, and let's say 35, something like this. These six blocks are there. Okay, fine. So now secondary index over non key. This is what non key. Why? Unsorted and even repeating value, that's over non key. Right. So remember, actually, see, understand properly. There is something. See, in this one, for this secondary index over non key, it all depends on the developer how they can make the indexing of such type of scenarios. Actually, you will see in book to book, different books, they you will find different solutions for that. Okay, so remember, okay, let's see in, if you will see your Navate book, right? So you will find out, let's say you have department number and it's a pointer, right? So again, we know the unique value should be here. So if we have two, right, we have two, three, then we have four, and then we have five, in this way. So block factor is four for the secondary index, right? So now some author says that they use this implementation in this one. So for value 2 over here, we have the 2 here, here. So means this pointer, we store the multiple pointer values over here in this way, right? So some claims like that. So basically, wherever the department number 2 is present, we use all the pointer values over here, and that will point to all the values in this way, right? And some other claims that instead of using this implementation, what they actually do is they create some some different space, or say some different it's a kind of block, right? So some different block where they have all those values which are having the same department numbers, for example, that is for, let's say, 2. So basically they will first point to the this part over here, and then this will contain all the values where 2 is present, that address of all the blocks, in this way, right? Same goes for 3, right? So you can see here how many 3 are present. 1, 2, 3, 4. So 1, 2, 3, 4. So this 3 will first go to this one, and then for every record block, actually, where the 3 is present, this way. Same for 4. How many 4 are there? I guess 1. That's 2 in this one, and this way. In this way for 5 as well. How many 5 are present? 2, I guess. And in this way over here, 5, 1 present here. Sorry, this one. And other 5 in this one. So in this way. Right. So basically, for accessing this part, right? So we will first go to this part where we have separately stored the addresses, or say the pointer values for those record, the block, where the values are present, actually, right? We call this as what? Redirect pages. Redirect pages. Remember, these are redirect pages. Means first we will go to over here, and then we will go to that specific block with the addresses of all the blocks stored over here. And after then, on the top of this one, you can create a next level. um, for example, 6 values here. So you can create the sparse index for this one, that is scale level index, right? Remember, this is what? On unordered over non-key. Right. So there is not a specific implementation. I remember whenever the developer designs for this one, the indexing part, it's choice of the developer how they can use. Right. So all these pointer values, even we can store here in multiple values over here, or we can create some redirect pages, and we can direct at these pages and then to the addresses in the block and access the value. Right. So some point, for example, secondary index over non-key is basically a sparse index. Remember this thing, right? So it's a kind of sparse index. Why? Because we have not, again, same concept, we have not included all the values. So it's not a dense index. It's a kind of sparse index. And the number of key used for the index, remember, the number of key used for the index are less than, obviously, the number of records in the database, right? Now, the input output cost, right? So for this one, the input output cost to access the record using secondary index over non-key with multi-level indexing, we used to find out is what? K plus, remember, the number of disk block, or say the database block access, or even you can use the pointer, that is your number of pointer in redirect base. Remember this formula, right? So this is what we see, the input output cost, and the indexing that is used is basically the sparse again. But remember, secondary index over the key is always dense, right? So we have the sparse over here, sparse indexing, but where is that? Over the key part, we always use dense only. This is the dense indexing, secondary index over key, right? So okay, I hope you have understood the indexing, primary, cluster, and secondary index over ordered and unordered, with key and non-key attributes, ordered fields, unordered fields, and all those, right? You understood about the input output cost as well. So go through this again, once again, and in the previous class, we will start with the dynamic multi-level indexing. That is what the standard data structure B and B plus tree is indexing. Balance, what's the difference between balanced search tree and why we move on to the B and B plus tree. We'll see everything, advantage, disadvantage, and node structure and all those things, right? So before that, try to go through the video again if you didn't understood anything. In the next class, we'll try some examples, obviously numericals, because this topic is completely numerical. We'll see some good previous year question papers of your graduation level, as well as your previous year questions from your competitive exams both, right? So remember the concept, remember the formulas where we used, and we'll see continue in the next class.